Hi there, welcome back to the channel. If you have been seeing some inverse trig functions in your calculus courses and you don't understand how they were derived, and maybe probably your teacher told you to just cram it or whichever way, I just want to show you the derivation. I'm going to show you in two ways, and whichever one you like you can use in further classes. But of course there is one other video that I'm supposed to make to explain something about the derivations I'm doing here. But so you let me know in the comment section if I should make that video if you don't understand what I am doing. In some parts you understand one part, so but if there's a part where I just bring in some identities that you don't understand, you let me know in the comment section if I should release the video if you don't understand personally. So let's get to it. How do we differentiate inverse trig functions? We are going to be using sine inverse of x. We'll find we use so that is the function y equal to this, and the function y equal to cos inverse of x, and the function y equal to sine cos tan inverse of x, and the function y equal to sec inverse of x, cot first. Either ways you want to do it. And 5, y equal to sec inverse of x, and number 6, y equal to cosec inverse of x. So we're going to be seeing how to do all of this. Okay, so let me show you the first method for sine. So I might not do both methods for each case, so I might just do one method for the rest. But let me show you the two methods that I can use using the first question. The first question says that we should differentiate y equal to sine inverse of x. Okay, now before you differentiate this, here's what you want to do. Now you know that if I say that sine theta is equal to something, maybe 0.11 something, remember? It's the same as saying theta equal to sine inverse of this thing, right? Maybe 3.1, let's say 3.1. It's the same as saying sine inverse of this. So which means that this 0.3 is actually equal to the sine of theta, right? From the beginning, right? So in the same manner, I can say that if y is the sine inverse of x, then x is actually sine y. I hope that is clear. X is actually what? Sine y. Now using the first approach, now you remember that sine of an angle is equal to that angle, sine of an angle is equal to opposite over hypotenuse, right? Okay, so in like manner I can say that the sine y that I have here is equal to opposite, which is x. X has a denominator 1, right? So it means that here is my opposite, x is my opposite, h is my hypotenuse. So if I draw my triangle, my right angle triangle, sine y, if this was y, sine y will be opposite, which is x. This will be x, hypotenuse will be 1. So how do we get my adjacent? So my adjacent is going to be adjacent is equal to hypotenuse square minus opposite square. So a will now be equal to the square root of hypotenuse, which is 1, minus opposite squared, which is x squared. So since x is equal to sine y, right? We can take dx dy. We can differentiate x versus y, and this becomes sine y becomes cos y in dy dx. You know that, right? Derivative of sine x is cos y. Derivative of sine y is cos y. So if that be the case, then it means that dy dx is equal to what? 1 over cos y. So I remember the cosine of y will be equal to what? Cosine over what? Adjacent over hypotenuse. And what's my adjacent here? Is this, right? Okay. And what's my hypotenuse? My hypotenuse is 1, right? My hypotenuse is 1. So that dy dx will be equal to 1 over cos y. Cos of this, my y angle, will now be equal to adjacent, which is this, square root of 1 minus x squared over hypotenuse, which is 1. So that doesn't count, so this becomes my answer, right? So this is method 1. Let me show you method 2. Now with method 2, you have to know what we call trigonometric identities, okay? So from here, I'll pick it from here, that x is equal to sine y, isn't it? Since x is sine y now, since x is sine y, remember or recall, before we recall, let's take dx dy. So we have dx dy will be equal to cos y again, right? Cos y as we had here, okay? Dx dy, okay? So by the time we invert it, just like we invert this too, we'll have dy dx is equal to 1 over cos y, okay? Now here's the thing. So you should recall in trigonometric identities that sine squared y, I'm using y in this case because of this our function, sine squared y plus cos squared y is equal to 1. So if this be the case, then cos squared y is equal to 1 minus sine squared y. So that cos y will be equal to the square root of 1 minus sine squared y. Is this clear? By the time we make cos substitute of formula, you're going to take square root of both sides, and then you have this. Okay? Now, by the time we impute this into the equation, dy dx will be equal to 1 over cos y. So cos y is now this, that's root 1 minus sine squared y. Okay? Now, how does it turn to this? You remember from the beginning we said that x is sine y. So if x is sine y, then x squared should be this one squared too, right? Which will be sine squared y. So it means that we can replace sine squared y by x. Then we have that dy dx will be equal to 1 over square root of 1 minus x squared. So you see they are now alike, right? All right. So here forward, I'm going to use this method, but you can use both methods in both cases. In fact, okay, let me use this first method. Maybe I'll be interchanging. Let me use this first method now for the second one again, so that you just see that they work the same way, or just so you master it. Okay, so we have the second one says we find that y is equal to cos inverse of x. So here, what do? The first thing to do is to say that x, if y is cos inverse of x, then x will be the cosine of y. Does that make sense? Yes. So from here, let's differentiate. Okay, but before we differentiate, we can test already that since cos y is this, it means that our adjacent is x and our hypotenuse is 1, because remember that cosine of something is adjacent over hypotenuse. Okay, so it means that if we draw our right angle triangle, if this is our y, then our hypotenuse is 1, adjacent is x, and if that be the case, it means that this place will be our opposite, and the value from what we calculated before was 1 minus x squared. It will be hypotenuse squared minus adjacent squared. That will be the value of the square root of that will be the value of our opposite. Okay, so if that be the case, we can differentiate from here that dx dy will be equal to what? Negative sine y. Remember that sine x, derivative of sine x is cos x, exactly, and derivative of cos x is minus sine x. So that dy dx, here we are turning it upside down, we also turn this upside down, 1 over or negative 1 over sine y. Okay, so if this be the case, remember that sine is equal to opposite, which is square root of 1 over x squared, over sine of something, sine y, will be opposite over hypotenuse over 1. So therefore we can say that dy dx, so this method is short, you can see that dy dx will be what? 1 over, what is sine y? Sine y is this, that is 1 minus, okay, negative, there is a negative, 1 minus x squared. So if you look at it very well, it's just negative that differentiates them. They are the same in quantity, but the negative differentiates them. Okay? Alright. So I won't be solving with the second method. I'll just go to the next one, which is number 3. So number 3 says that y is equal to tan inverse of x. And what is tan inverse of x? So from here we can tell that x will be equal to what? The tan of y, if y is tan inverse of x. Does that make sense? Think of it as pretty much like y is equal to x over tan. But tan is a function of something, so that's why we don't normally write it this way. So that by the time you cross multiply, you have tan y. That's how to think of it, but that's not exactly correct. This notation is not correct. Okay? So we now have that if x is tan y, then dx dy will be equal to, I'll just use the second method directly. Dx dy will be equal to sec squared y. Sec squared y. Derivative of tan x is sec squared x. Okay? So from here, dy dx will be equal to what? We interchange 1 over sec squared y. Okay? Now remember that sec squared, now you have to know trig identity. Okay? So I said recall that 1 plus that tan squared x plus 1, or tan squared y in this case plus 1, is equal to sec squared y. Sec squared y. Is this sec squared x plus 1 is equal to tan squared? So you have to really remember that thing. Can't even remember now. But it's very simple. Look at how you do it. It's very simple. So simply say h squared is equal to o squared plus a squared. Alright, if you divide through by this, you have a squared by a squared over a squared. So 1 over a, opposite over adjacent, that's tan squared. Hypotenuse, that is cos. 1 over cos is sec, so I'm correct. Tan squared, this okay. So it's correct. Alright, so there is a trig identity that says that tan squared something plus 1 is equal to sec squared, that thing. Alright. So if this be the case, then we can use this to replace our guy, so that dy dx will be equal to 1 over, this is sec squared y, right? This guy is sec squared y, we need to replace it. So we have tan squared y plus 1, or 1 plus tan squared y. Okay? And remember that tan y, that x is tan y, right? Therefore, x squared should be tan squared y, isn't it? Okay, so we can replace this by x squared, so that dy dx will now be equal to 1 over 1 plus x squared. So that is the derivative of tan inverse of x. Let's do the next one, which is cot inverse of x. Cotangent inverse of x. Cotangent inverse of x. Cotangent inverse of x. All right. Number 4 says to find y equal to cotangent inverse of x. To solve number 4, we have y equal to this. So if y is equal to cot inverse of x, then x should be what? Cot y. Does that make sense? So from here we can take dx dy to be, if you differentiate cot y, you get negative cosec squared y. Okay, negative cosec squared y. So let us remember our identities. Recall that Now, if you want me to make a video on how we get these identities, like I said before, tell me in the comment section. Remember that cosec squared y is equal to 1 plus cot squared y. I guess this is correct. So if this is correct, then we can already replace it here so that the first from here dy dx, that is inverse, will be equal to inverse of negative cosec squared y. And cosec squared y is already this. So dy dx will be equal to 1 over, we should not forget our negative, cosec squared y will become 1 plus cot squared y. Okay? And cot, now x from the beginning is cot y. So if x is cot y, then x squared will be what? Cot squared y. So we can therefore say that dy dx is equal to 1 negative 1 over 1 plus, what is cot squared y? That is x squared. And that will be the answer. Okay, so let me solve. Okay, now, let me just solve one more, and you solve the other and give me the answer in the comment section. Or okay, so that will be it. Do want to subscribe to the channel and click the bell notification. Solve. Let me. So you should solve number 5 and number 6 and send it to me, to send your answer for verification on to my WhatsApp, or just drop it in the comment section just to show me that you now know how to do it. God bless you as you subscribe and share the video with your friend. Good night.